Okay, so with the first one, when we already have like denominators, if we're adding and subtracting fractions, we don't have to do anything with the denominators. They're already the same. So what we would do is just add the numerators. So on number 1, 3 plus 2 is 5. So 3/8 plus 2/8 is 5/8. We're done. Okay? Now, with number 2, what would we need to do when we're adding fractions like 1/2 and 2/3? Find a common denominator. What is a common denominator for 2 and 3? 6. Okay, so we want a denominator of 6. So what does the first denominator have to be multiplied by to turn into a 6? 3. So what we do is we multiply this entire fraction by 3/3. Well, 3 divided by 3 is just 1. So we're not changing the value of the fraction. It keeps the same value, it just changes forms. So this becomes 3/6. And then what does the second fraction get multiplied by? 2. 2/2. And it becomes 4/6. Okay? And 3 plus 4 is 7. So, those same, if it would simplify, you should. Yes, sir. Okay? So, the same process is exactly what we're going to be doing, but we're going to have variables. We're going to be looking at different expressions. So, let's take a look at number 1 on the notes you picked up today. We have 2 denominators, 6x and 3. So, a common denominator for these 2 denominators would be 6x. You're right. So, this first fraction is good. It's already over 6x, so it doesn't need to be multiplied by anything. Now, this one happens to be subtraction. What we can do with subtraction is change it to adding the opposite of everything in the numerator. This numerator just happens to have 2 in it, so it becomes -2. But if it were x plus 2, it would become -x minus 2. Everything changes when we have subtraction. All right, now this denominator has to be multiplied by 2x to turn into 6x. So we must also multiply the numerator by 2x. And -2 times 2x is -4x. Now, if the numerator had a common factor that we could pull out, we might be able to reduce, but the numerator does not. So in this case, we have subtraction. We can't do any reducing. We're done. That's it. That's all there is to it. Okay, number 2. We're trying to find a common denominator. Well, this denominator actually has a common factor of 5. And so our approach when we have these rational expressions is to go ahead and factor our denominator so we can truly see what we're working with. All right, so this is 5 times x minus 4. And this is x minus 4. So our common denominator would be 5 times x minus 4. So once again, this first fraction, we don't need to do anything with. It's 2. But the second fraction needs to be multiplied by 5. So this becomes plus 7 times 5 is 35. Now this time we can actually combine these terms. So we should, and we get 37 over 5 times x minus 4. Now sometimes this will reduce and cancel. In this case it doesn't. Now, I'm going to allow you to leave your denominators in factored form. Okay? I'm going to allow you to leave the denominators in factored form. So let me write this down here. You may leave denominators in factored form. Let's take a look at number 3. We have another subtraction problem. So the first thing you probably want to do is change it to adding the opposite of everything in the numerator. But once again, we have a very simple numerator. And then we will factor our denominators. The first one doesn't factor. The second one has a GCF of 3. Okay? So this is x plus 2. This is 3 times x plus 2. So that common denominator would be the 3 times x plus 2. So the first fraction just gets multiplied times 3 over 3. So that makes 21 plus a negative 4, which is 17. And once again, this one does not simplify. Once we find that sum, the 3 and the 17 do not reduce. So we're done. Okay, number 4. This is addition, so we don't need to change anything. But this factors to y plus 3 times y plus 4. So that's our first step. After we distribute any negative, if it's subtraction, to factor our denominators. So that would be our common denominator, y plus 3 times y plus 4. So when we're looking at this problem, this first fraction would need to be multiplied by the y plus 4. So here we have 3 times the y plus 4, and then we have plus 2y. So we can distribute this, which gives us 3y plus 12 plus 2y, and then we can add like terms. So 3y and 2y are 5y plus 12 over y plus 3 and y plus 4. So take a minute and digest that.
So you can only leave it in factor form if it's in the denominator.
Correct. Well, actually, if we found that some are different and then the numerator would factor, we should do that. And I have a couple that work out like that we're going to work together in just a moment.
Did you grade the test?
You get back everything today.
Nice. Is everything in
No.
That's what's scary about it.
It is scary.
It's in
It is
I'm
scary.
all over it.
The quizzes on Friday were fabulous. Overall, there was a hiccup here and there, but overall they were really good. And then the test, a little mixture. There were some that were really good, like quite a few hundreds. So, all right, number 5. All right, number 5. The common denominator is 12x. Oh, wait, this is a U try. 5 and 6 are U try. No, just 5. 5 is a U try. And then 8 is going to be a U try when we get there. So 5 is a U try, so you try it.
Can I do 6 too?
If you want to.
Whoa, 6 is really good.
It is. That's why we're going to do it together, so you don't have to.
I think I can handle it.
Okay, so on number 5, that common denominator should have been 12x. So that first numerator needs to be multiplied by 3 over 3, which gives me 15 plus 7. And I just wanted to see if you guys could catch this. When you add those two, did you notice that in this case, we can simplify? So 2 goes into both of these. 2 goes into 12 6 times, 2 goes into 22 11. So our actual answer is 11 over 6. And that's it.
Can I try number 6?
You want to talk about number 6?
Yeah.
Sure. Okay, so Chase got a little ahead. What do you think the common denominator is for number 6,
X
Chase?
minus 35.
Okay, it's going to be the product of the two. And here gives you 35. But we have to have both whole expressions. Okay? So, don't even.
What's your math grade, bro?
Only those people that try.
69.
Only those people that try can succeed. So, you should never make fun of somebody who's trying. Those are the only people that have a shot at being successful. All right, so 2 times x is 2x. 2 times negative 7 is negative 14. And then we have to distribute here. So we get 3x and a negative 15. So when our denominators are completely, totally different, and it almost seems like the first one gets multiplied by the second one gets multiplied by the first one. Yeah, that's what it is. Okay, so this gives us 5x minus 29, which doesn't have a GCF. And that's all we can do. So we leave it as 5x minus 29 over x minus 5 times x minus 7.
Alright, I need to get this.
No.
Alright. So now, this one has a GCF of 4, and so this is easy. What does this numerator get multiplied by? And denominator? 4.
Easy. So I'm getting behind.
So that gives us 12x plus 6x over 4 times x minus 6.
So it's gonna be 9
Which is, yes, it's going to be something that eventually simplifies. And you're right. When we get here, we see that 2 goes into 4 2 times and 2 goes into 18 9 times. So our simplified sum can be represented by 9x over 2 times x minus 6.
Is it? We kind of wrong to be like 2x minus.
If you distribute back in the denominator and you distribute correctly, I will not count off because it is not wrong. I'm just allowing you to leave it in factor form for the sake of time. Yeah. All right, number 8. This denominator factors to x, not x anything, y plus 10 and y plus 2.
Installing.
Just a few minutes when I'm done.
Sorry.
Alright, so this has to be multiplied by y plus 2. So we get 5y plus 10 plus 4y over y plus 10, y plus 2. Okay, and so this is just giving us 9y plus 10, and that doesn't factor, and so nothing's going to simplify, nothing's going to cancel. That's it. That's it. Okay, so I want you to go ahead after you finish this one and flip it over the back. We're going to do 3 together because the back has some great problems. It's going to remind us about some different types of factoring when the leading coefficient is not 1. The back has some problems where we also need to factor out a negative and we need to be on the lookout for that. Okay, so the 3 that we're going to do together on the back are 4, 6, and 10. Okay, so number 4 already has a common denominator. So when it has a common denominator, we just go ahead and add our numerators. So let's do like terms. 3x squared and negative x squared. Negative 2x squared is x squared. Negative 4 and positive 4 cancels. And then positive 2 and negative 3 is negative 1.
Over x minus 1.
Okay, now, this is what we always want to be aware of. When we have found that sum or difference, if the numerator or denominator could factor further and simplify further, we should. Now, what does this numerator factor to?
X plus 1 and x minus 1.
X plus 1 and x minus 1. And now it's written as a product.
X plus 4.
So the answer is just x plus 1. Okay, so once again, on these puzzles, you get points for your work. Learning about the different mountain ranges and the different continents is just like bonus. It's exciting.
Where's M?
And you probably already know which one of them is. What's the African one? Okay, maybe not. You'll get there. Alright. This one. These are not the same.
Like what?
Alright. When we look at our second denominator, do you see that if I factored a negative out of this negative x would become a positive x.
Oh.
And this positive 2 would become a negative 2. Now, that's not something you'd be looking for, except if you look at the first fraction, you're like, hey, these are really close. They're just the opposite signs. So when you see that, to get the common denominator, you're going to have to factor a negative out of one of them. And I really like my variable to always be positive. So I'm factoring a negative out of the one that'll make my variable positive. Okay? So in this case, our common denominator needs that negative and x minus 2. So this has to be multiplied by negative 1 to get the negative. So that makes a negative 2x plus y, which we could write as y minus 2x. You could. Over 2 minus x. You could. These are equivalent.
What's the answer? Is it C? C. No, that's not it. Crap. Is that it? C.
Yeah, that's definitely.
No,
Six.
because
Yeah, that's definitely C.
6 is C.
Different.
Alright, what if I factored the negative right here, guys?
It's not a negative one, so
What if I factored the negative out of that? Now what happens? This negative cancels with that one, so we're left with 2x minus y over x minus 2,
C.
which is C. Okay, now, I chose number 10 because we haven't factored ones with the leading coefficient in a little while. And I'm going to go back over the method I taught you because this coefficient is 2. And there's only one way to multiply and get 2. That is 2 times 1. That is the absolute only way to multiply integers and get a product of 2. 2 and 1. Now, the constant is 3. 1 times 3. But we have to be careful where we put things. If we put the 3 here and the 1 there, don't do it. That would give us 6 and 1. Is there any way to turn that sum? And no. So that's not where it goes. We have to put the 3 here and the 1 here because that gives us 2 and 3. So if the 3 is positive and the 2 is negative, what is 3 minus 2? 1. Okay? So let's go back over that method of factoring in this second bunch. Okay? We do. We need a 6 though. So to get 6, we can do 1 and 6 or 2 and 3. And if we do a 2 here and a 3 here, do you see we get 4 and 3? If we made the 4 negative and the 3 positive, negative 4 and positive 3 makes negative 1. And that's how they factor. Okay. So I will show you the other method for factoring for both of these now. It's where you multiply this times this, and you get negative 6. And so you split this into negative 3, positive 3 and negative 2. And then you take the x out of the first group, and it leaves you with 2x plus 3. And then you take a negative 1 out of the second group, and it leaves you with 2x plus 3. So we know it's 2x plus 3 times x minus 1. So this is the term splitting way to do the same problem. I'll do the term splitting way for the next one now. So once again, if you don't like trial and error, or you struggle to multiply correctly, you would want to try this method. So this is negative 12. So we would split this into negative 4 and positive 3. And then these two have a 2 and an x in common. And then these two have a 3 in common. So it gives you x minus 2 times 2x plus 3. We get the same thing, it just takes more work. Okay? Now, let's go back to the adding and subtracting part.
Show us the answer.
Okay, a common denominator has to have all 3. I don't think that's funny at all, by the way. Everything has to be accounted for in the common denominator. So both of those and both of those, and now they're all there. So this first one needed an x minus 2. And the second one is missing the x minus 1. And that's how we get the common denominator. So this gives us this product, 4 times x, 4x squared. 4 times negative 2, negative 8x. 1 times x, positive 1x. 1 times negative 2, negative 2. Plus 7x minus 7.
What was going on?
Huh?
What's very much behind?
Okay, so I'm going to switch to green, and we only have one squared term, 4x squared, negative 7 and positive 7 go away, and then minus 9. Okay, 4x squared minus 9 factors to x plus 2, 2x plus 3 and 2x minus 3.
This is other stuff. This is so much.
And then what happens here?
Uh,
They cancel, and this is our answer.
I don't even see it up there.
Oh,
Oh.
oh,
N is O.
yeah, that's it.
Oh.
Okay, so you guys have the rest of class to work. Probably number 10 is one of the harder problems on the page, but we've knocked it out.
Do you want to do that to me?
The only way you get credit for this is if you have work. The answers to the mountain ranges or the mountains are just adds to your general knowledge.
Trying to spit you a piece of it.
How